Take a moment to show some of the features of the Gas Lab simulation program. When the program opens up, you will get a noble gas with the particles moving around inside a rectangular chamber. These little balls represent 1 mole of gas. So you'll notice there are 90 moles of gas inside this chamber, so there'll be 90 little balls. You'll notice they're different sizes. That's because the box is 3-dimensional, so as the particles get closer to the front, they're going to appear larger. When the particles move closer to the back, they will look smaller. So these particles are actually moving through all 3 dimensions as we watch them. Okay, so what you can do here is if you want the volume of your chamber, you can use the length, the width, and the height. The width you can get by using your on-screen ruler. For your other 2 dimensions, it will be mentioned in the bottom where you have other data. To get the pressure and temperature, you can get those from the gauges that you see down at the bottom, which will be live readouts of what's happening inside the chamber. Again, the number of moles will be told to you. The average speed of the molecules inside will be told. The mass of your noble gas for 1 atom will be told to you. And the pressure of the environment around your chamber, not the pressure inside the chamber, will also be listed. You can have your chamber with conducting walls, they'll be the gray ones, or insulated walls, they'll be the ones that look like they're made of Owens pink. When you have your chamber insulated, no heat will be able to get in or out of your chamber. When you set your thing to conduct, the chamber will be at the exact same temperature as the environment containing the chamber. You'll have access to 8 different environments. So as you click these, your chamber will come in contact with a new environment that has a different temperature than the previous environment. So we will see changes taking place to different parameters based on the environment in which our chamber is placed. We can change the gas inside our chamber. We want to keep monatomic gases so that you'll have access to all the noble gases from helium straight on through to radon. You'll be able to manually move the piston, and when you do that, it will give you 2 seconds to have the piston and the chamber come back into equilibrium, and then you'll be able to move the piston again. Okay, with all of this at your disposal, you should be able to look at the connection between the mass of the molecule and the speed of the molecule, the connection between the temperature and the speed. You should be able to model isothermal processes, isochoric processes, isobaric processes, and adiabatic processes. So I will put together another video that shows you how to do all the different processes. I just wanted to make sure that you were aware of how these different controls influence the behavior of the gas.